Well, it gives an example. There's like a rocket problem in there. And it talks about you have a model rocket and it takes off from the ground. It goes up to a certain point, and at that point, it runs out of fuel. And maybe that's, say that's at time equals 20 seconds.
Okay.
But up until that point, it accelerates at, it accelerates at, say, 20 feet, or let's go like 15 feet per second squared, going up. Let's use meters. Meters per second squared. And then after it runs out of fuel, what's going to happen?
Sort of fall.
Will it fall right away?
No, slow down.
Yeah, so it'll slow down and it'll accelerate. And we'll talk about that in a minute. But so if somebody just described to you, they said there's a model rocket that launches at 0. And it accelerates up at 15 meters per second until it runs out of fuel at t equals 20 seconds. How high does it go? And you're like, okay, how am I going to solve that?
Yeah.
So what you want to do is, these are, let's see, velocity final equals velocity initial plus AT, x final equals x initial plus v initial t plus AT squared, and then v final squared equals v initial squared plus 2a change in x. And these will actually apply in y, so you just imagine the x's are all y's. So you've got these 3 different variables in here. Well, actually, it's 4, because you have position, velocity, acceleration, and time. So what you can say is, well, we were given an acceleration for the first part. We're given a time of when it runs out of fuel. But let's fill in the rest of these values. So let's start here at the bottom. Let's say y naught, that's our starting position. So if it launches from the ground, what's your initial position?
0.
Y naught equals 0 meters. So velocity equals, when a rocket takes off, how fast is it going initially, when it just right when it starts?
Right when it starts.
Yeah. I guess you kind of have to assume this, but.
It's kind of really pretty fast.
Well, I mean, the fuel starts burning and stuff, and it starts to lift off, and then it starts to speed up as it goes.
Right.
So we're kind of assuming that it starts at 0 at the bottom,
Okay.
and then our time is right at the beginning. It's going to be 0 seconds. So that's this point right here.
Okay.
And then we know that it accelerates at 15 meters per second squared during this time. And then it hits this point. So let's call this point 1. So y1, v1, and we know that our t is 20 seconds. So do we know y here?
No.
No, not yet. Do we know v here?
20. 20 seconds.
No, that's the time.
Oh.
So this is velocity that we want to
No,
find.
we don't know that yet.
So we'll ignore that for a minute. What about this top point? We'll have a y position, we'll have a velocity, and we'll have a time. So do I know what this one is?
No.
What about the velocity?
No.
So what happens for a rocket when it reaches its highest point?
Oh. It falls.
Yeah, so it comes up, it's going up and up and up, and then right here, it runs out of speed and stops.
It goes down.
It starts to go down.
So it say it reached 0.
Yeah. So we know that our velocity at the top is actually going to be 0 meters per second. And time, we don't know yet. And then this acceleration acceleration 2. What is what does it accelerate at after it's ran out of fuel?
Doesn't accelerate, like 0.
Well, that would mean that it would just keep going at the same speed forever, right?
Oh, so when it runs out of fuel, like,
Mhm.
it goes negative,
Yeah, so what's slowing it down? What's making it slow down?
lack of fuel,
Right, and
the gravity.
and the gravity, exactly. So this would be the acceleration due to gravity, which is negative 9.8 meters per second squared. So these are the things we know. So this is a good way to go about solving a problem is, I mean, if we just looked at what we were given, there's this and this, right? We didn't have really anything else. Now we know 3 more things, well, 4, 5 more things that we just looked at the graph and we found. Okay, so what do we need to find in order to find this very top point? This is what we're looking for.
What do I need to find?
Yeah, so we want to solve for this. Can we just go here and say, oh, let's plug it into this equation?
No.
'Cause
We have all the,
Well, let's see. We have an or a y initial, right? Because it started at 0. We have a velocity of 0 down here, right? But we don't have a time, so that's true. We don't have. The other problem is that we have 2 different accelerations. So when you use these equations, you can only look at one piece of motion at a time. It has to have the same acceleration. These are actually called constant acceleration kinematics. So if your acceleration changes at all during that time, then you can't use any of these equations. But luckily, this is the kinds of problems that we're given. So from here to here, you can look at, and from here to here, you can look at, but you can't look at them all together. So we're trying to find the total height. So which of these do you think would be helpful to find?
total height. Y1 would be nice.
Yeah, so let's see if we can solve for y1. So this is what we want right here. So we want an equation that has a y in it. So which ones? Could we use this one to find y1?
That would be VT or VF.
Yeah, so this is velocity final equals the velocity initial plus acceleration times time.
No.
So that doesn't help us. And then you just replace these with y's. So this one has a y final position. And then this one also has a y, because you can look at this way, v final squared equals v initial squared, plus 2a y final minus y initial. That's the same thing as saying delta y.
Okay.
So you could use one of these two. So what else do you need in order to use these equations? For this one?
We need velocity initial.
So do we have a velocity initial?
Yeah.
So that one's good. Wait, initial. So we got this one, we're good there. This is the one we're looking for. Do we have this?
Y initial. Yeah.
And then do we have this?
Yeah.
And then that leaves us with time. So we have the change in time from here to here.
No.
Well, so we got time here is 20. Time here is 0.
Oh, yeah, I guess we do.
So that means we have everything that we need to make this equation work, right? So you just start out, you start plugging things in. So your y final is what you're looking for, or y1. So y1 equals y initial, what's y initial?
0.
Plus v initial times time, so what's that?
The initial 0.
What's your time?
0.
But yeah, this will all end up being 0. But which time do you want to use here?
Probably the 20.
Yeah. Because otherwise it'll just give you your position at this point, which you already know. So that's going to be 0. Plus 1/2, what's your acceleration?
15.
And then your time?
20.
1/2, 15 times 20 squared. So then you know that's 0 and that's 0, so y1 is going to be equal to 1/2 times 15 times 20 squared. Well, this is 400 times 1/2, so this would be 200 times 15. So it's 3,000.
Yeah.
Okay, let's put that in here. 3,000